been set equal to 4x minus 1. Val, how'd you solve this? What'd you get? You added 1 to the other side, and you got 5. Love to see it, Val, but my answer was 19. You have to plug it back in. Very good. Does it matter which one you plug it into? No. Why? They're going to be the same, right? Because the diagonals should be the same length. So if you plug it into this one, you get 20 minus 1, which is 19. Okay, so the measure of each diagonal was 19. Benji, we good? Yeah. Zach? Okay. Any questions on this guy? Go ahead, Gio. All right. So before we jump into today's lesson, okay, I want to talk about trapezoids and kites. Hey, FYI people, we've talked about what kind of shapes all in the past. Parallelograms. Guys, guess what? These are not parallelograms. Okay? Now, probably the most important concept that I need you guys to understand is on the very last slide of the notes. So if you guys can go, once you're done copying down that these are not parallelograms, go all the way to the very last slide in the notes. A trapezoid is a quadrilateral with exactly how many pairs of parallel sides? 1. Circle that 1. It's no longer 2. We're not dealing with parallelograms. Each of the parallel sides is called a base, and the non-parallel sides are called the legs. The base angles of a trapezoid are two consecutive angles whose common side is a base. So in other words, it's the 2 angles on the bottom or the 2 angles on the top. They both must be touching the same base though, okay? Are what equal? Not right now, right? Because do you see how B is much smaller than angle D? Okay? Base angles when you're dealing with an isosceles trapezoid, then they're equal, okay? But right now they are not equal. Okay. An isosceles trapezoid. Here we go, Dylan. If the legs of a trapezoid are congruent, so those 2 sides that are not parallel, if those end up being congruent, the trapezoid is what we call an isosceles trapezoid. And it looks like the figure down below. Understand there's only 1 pair of parallel sides, and those are the bases. Those other 2 legs should not be parallel to one another. How is this similar to an isosceles triangle? What? Well, what were those 2 sides called in a triangle? The two congruent legs. Okay. You okay, Amanda? Do you need a moment? Moving on. 3 theorems, okay? The first one, the isosceles trapezoid base angles theorem. This is what Dylan just said. He asked if in a trapezoid your base angles are congruent. Only in what kind of trapezoid? Isosceles, but it is true, okay? Both sets of base angles are congruent. So the angles that are next to each other. So for example, B is going to be congruent to C and A is going to be congruent to D. Now the converse is also true. So if we didn't know that this trapezoid was isosceles, if one pair of base angles was congruent, I would know it's then an isosceles trapezoid, okay? So the converse of this theorem also works. And then the last theorem is that only in an isosceles trapezoid, your diagonals are the same length. They're congruent to one another, okay? Just like what other shape? Who's been paying attention? Not a rhombus. A rectangle. Very good. A rectangle, okay? It was part of our warm-up as well. All right. Guys, I would like us to skip this one. Okay, you can cross it out. If we have time, we'll come back to it, but for now, just cross it out and we'll erase if we need to go back there. The next thing we're going to talk about is something called the mid-segment. Now, the mid-segment. What do you think is the root word for mid-segment? Mid, right? And what did I say mid usually means?
Middle.
The middle or the midpoint, okay? So the mid-segment is the midpoint of, it's going to pass through the midpoint of both of the legs. So it's going to cut each of the legs in half. It's also going to be parallel to what? The bases. So put parallel markings on all three of those, okay? It's going to be parallel to the bases and it's going to cut the legs exactly in half. Do you guys remember the mid-segments in triangles?
Yes.
It's very similar, right? The mid-segments in triangles also went through the midpoints of each of the sides of the triangle, and they were also parallel to the bases, okay? All right, now, the mid-segment, it's really cool because it's exactly half of the sum of the bases, okay? So in this example, XY is our mid-segment, and it is exactly 1/2 of BC, the top base, added with AD, which is the bottom base. So the red piece and the green piece added together, divide by 2, and you get the blue piece. This formula. Okay? And just know that they're all parallel to one another. So they should have 3 parallel markings on all of them. Okay? Just by eyeballing this diagram, guys, how did I know that XY was a mid-segment? It's in the middle. So do you see those congruence marks? Those should be there if it wants you to use anything regarding a mid-segment, okay? All right. And lastly, let's talk about kites. So this is our last and final shape of chapter 7 piece, okay? A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. Guys, what does that word consecutive mean?
Like adjacent.
Yeah, it's like next to it, okay? So, remember in parallelograms, what sides were congruent in parallelograms?
Opposite.
Opposite. Are these parallelograms? No. So in these kite examples, the sides that are next to one another are congruent, okay? So AB is congruent to AD and BC is congruent to DC, okay? It creates a kite. Go back. Now, the properties of kites, there's 2 theorems that you need to know, okay? The first theorem says that the diagonals of a kite are perpendicular. That means that there's a 90-degree angle where the diagonals intersect. Okay? And the second theorem is that your angles that are opposite one another are congruent, but only for one pair of them. Okay? So B and D are congruent here, but what 2 angles are not congruent? A and C. And I want you guys to actually fill in like numbers for these sides so you can visualize it. Let's say AB was 5 units. What would AD have to be then? 5. And let's say BC was 7. What would DC have to be? 7. So do you guys see how angle B is in between, it's sandwiched between a side of 5 and a side of 7? And angle D is sandwiched between also a side of 5 and a side of 7? That's how I want you guys thinking of these. If they share the same length for the legs, right, then they're going to be the same angle. But do you see how A is sandwiched between both 5s and angle C is sandwiched between both 7s? Those are not going to be congruent, okay? They're going to be different angles. All right, so let's do some examples. Okay, so let's start by trying to find the measure of angle A with this figure, given that that angle C is 100 degrees. And it helps, guys, to write down what kind of shape this is. Hannah? It's a quadrilateral. Very good. Let's put quad. Very good. All interiors add to 360 degrees. Excellent. What else do we know about this figure? Yeah. Very good, Anja. It's an isosceles trapezoid. I'm going to put trap for trapezoid. All right. What do we know about isosceles trapezoids?
They have two congruent sides.
They have two congruent. The legs are the same. Very good. That's how we determined that it was isosceles, right? Was because BC was congruent to AD. Bingo. Base angles are congruent. Write that down. Base angles congruent. That means which two angles give me two angles that need to be congruent in this figure? C and what? C and B? C and D. It's a trapezoid, but do you see how it's kind of turned on its side? Remember, base angles must lie on the same base. Your bases are the two sides that are parallel. Do you see how C and D lie on the same parallel side? And what other two angles lie on the same parallel side? A and B. So these two need to be congruent. So knowing this information, what other angle do I know?
D.
D is how much? 100 degrees. So as Hannah said, we have how many degrees in the whole thing? 360. And how many have I already used? 200 degrees. So how many degrees do I have left for these two? 160. And I got that by doing 360 minus 200, right? Which gave me 160. Are you guys with me? Okay. Now, I know that A and B must be the same measure, correct? So what can I do with that 160 to figure out the measure of each? German? Divided by 2. So you take 160 divided by 2. What's the measure of angle B? 80 degrees. What's the measure of angle A? 80 degrees. So the measure of angle A, and our final answer is 80. Make sure you put a degree symbol there. Good practice. Yeah. We'll get there. But yes. Yeah, go ahead. All right, guys, the next problem is very, very similar. You should try it on your own. Try to figure out the measure of angle F. Try it right now. I'll give you 2 minutes, and then we'll talk about it. Go. Okay, the measure of angle F is 131 degrees. I need you to talk about it in your group and go. Go. All right. Where did you guys start? What did we start with? Amanda?
Okay, so I put 49 at E.
Very good. Why does this have to be 49 as well?
They're congruent.
Why?
Because
They're congruent, not because they're opposite. What kind of figure was this, Amanda?
it's an isosceles trapezoid.
Very good. And I know that base angles in an isosceles trapezoid are congruent. All right, what'd you do from there, Amanda?
Okay, then I added 49 to the length, I got 98. And then I did 360 minus 98.
360 minus
And then I divided that by 2.
262.
And I divided it by 2.
262 divided by 2, and you got 131 degrees. All right, Sophia, do you mind saying what you noticed before? Yeah. Mm-hmm. If they go across, right? What do you notice about 131 and 49? Part of the same leg. They're supplementary. Is that true for this 131 and this 49? Okay, that's your shortcut. Remember, in a trapezoid, okay, if two angles lie on the same leg, they should add up to 180 degrees, okay? In an isosceles trapezoid, they're still going to add up to 180 degrees, but remember, your base angles are also going to be congruent, okay? All right. Learn about next example, we have KB is 21.9. So we do 21.9 here. And we have MF is going to be 32.7. We need to find FB, which is this guy right here. All right? Daniel?
Divide 32.7 by 3.
Divide 32.7 by 3. So I think you're thinking of a centroid with the medians, right? And the medians get cut into thirds. This is an isosceles trapezoid now, so we don't know that it's cut into thirds. Dylan? FB is equal to 10.8. But I want someone to explain why I was able to subtract these two values. Hayden?
Because the KB and MB are congruent.
Ooh, why are KB and MB congruent? You don't know? Because what? They are part of diagonals, and they're part of diagonals in what shape? An isosceles trapezoid. And we know that diagonals in an isosceles trapezoid are congruent. So both of those pieces needed to be 21.9. That means that BJ would also be congruent to FB, right? So it's going to be proportional all the way around. So we just took the 32.7 and subtracted the 21.9. Does that make sense, guys? Well, does this work for any trapezoid? No, only for what kind of trapezoids? Isosceles trapezoids, okay? In the notes. Actually, all right, guys, let's do this one. This is going to be our last example. We're going to skip, actually. All right. In a kite, ABCD, the measure of angle DAB is 54 degrees. Let's fill that in there. Where's DAB? At the bottom, right? Right over here. 54 degrees. And the measure of CDF is 52 degrees. Where's CDF? It's like that smaller piece on the right, right? What did it say, 52 degrees? Yeah. Okay. Now, what shape was this? Okay, so we have some congruency on a kite, right? Two consecutive sides are going to be congruent. So which sides are congruent in this kite? Yeah. If I'm not repeating it. Who can answer my question? C, D, and BA. No. Yeah. Ooh, angles. Yes, these two angles. Very good. These two angles need to be congruent. Okay? Because they're opposite angles in the kite. But what sides need to be congruent? What sides? Yeah, Hannah?
BC, DC, and BA, DA.
Bingo. Those sides need to be congruent. Okay, so now it wants us to find the angle BCD. Where's BCD? It's at the very top. Do you guys agree? It's this angle up here? Would you guys agree that that angle is part of this triangle?
Yeah.
Okay. What do you know about that triangle then? It's isosceles. How do you know it's isosceles, Christian? Okay, it has two congruent sides. What do we know about isosceles triangles?
The two bottom angles are the same.
The base angles are the same. So what other angle also needs to be 52?
B.
Not angle B,
CBD.
CBD. Okay? But that's not what it was asking us for. What is it asking us for? Daniel? BCD. How do I figure out this guy?
You subtract or divide 54 by 2.
No.
You add them together and subtract them from 180.
Add 52 together and subtract it from 180. So we're going to do 180 minus 104 because that's what 52 plus 52 is.
72.
And we should get 76 degrees. So this angle is 76 degrees. It just died. Okay. Peeps, we're done with chapter 7. Turn these in. No more shapes to learn. If I'm going to stress one thing to you guys, okay? Conceptually, were any of these lessons necessarily very difficult? No, most of you understood it right away. But there's a lot of information about all of these. Do you guys agree? Like in total, there's a ton of theorems about a bunch of different shapes. That is going to be your main goal. How do we get better at stuff like that? Study, Quizlets, like flashcards. You guys be on top of it. You have to know all your theorems, all your shapes before when? Friday. I recommend being really prepared coming in Thursday. So use Thursday as like a practice, as like a gauge for how well you're going to do on the exam, okay? Now you guys can go ahead, just cross out example 5. We're not doing example 5 because it involves the Pythagorean theorem, and we haven't learned that yet, but we will learn it, okay? I don't know why they put this example. Okay, so the most basic shape that we've talked about, right, with 4 sides is called what? A quadrilateral. It has no like restrictions. It's any shape that has 4 sides. Do you guys agree? Then we started talking about what? Parallelograms. And we were like, okay, parallelograms, what defines a parallelogram? What makes something a parallelogram? 2 pairs of parallel sides. And then we talked about even more specific parallelograms, which were what? More specific parallelograms. Rectangles and rhombuses. And then the most elite of all of them was the square, because everything's congruent in a square, right? All the angles are congruent and all the sides are congruent. So squares is like the most elite. Today, what we're learning about, they are still quadrilaterals because they have how many sides? 4. But they're not parallelograms because they don't have 2 pairs of parallel sides. And those are trapezoids and kites. And the most elite of these that we're going to learn about is something called an isosceles trapezoid. You guys have heard the word isosceles before. What does isosceles mean? Yep.
2 pairs of congruent sides.
Yeah, 2 pairs of congruent sides. So in this trapezoid, right, if these 2 sides are congruent, it makes it isosceles. Just like a triangle. Do you remember when the 2 legs of a triangle were congruent? We said that it was isosceles. The same thing happens for trapezoids. Okay? All right.